All right, welcome back to pre-calculus. We did enough exponential equations. Let's do a logarithmic equation. So here we have log base 4 of 5x minus 2 plus log base 4 of 3x minus 4 is all equal to 2. Now, on this problem, eventually I want to take the anti-log of both sides. That will get rid of the logs, and that'll allow me to solve the equation. Just like in the previous equations, we took logarithms of both sides at the end. Here we want to take the anti-log both sides of the equation about at the end, well, a little bit before that. But I can't, just like logarithms don't distribute over the thing, I can't like get rid of the anti-log like this. It doesn't work like that. It does, but not quite. So what we're going to have to do first is we're going to have to pile this up into one big logarithm for us to take the anti-log of. Okay, and the way we do that is there's a logarithmic um, property that lets you do this. It says log of AB is equal to the log of A plus the log of B. Well, the cute thing about this is it goes backwards too. Okay, so we have the log of A plus the log of B. We're going to push them together. So we're going to say this is the log base 4 of 5x minus 2 times 3x minus 4 equals 2. Don't touch the 2 just yet. That's coming. Okay. And now we have to go through and distribute the stuff out. Okay, so we have log base 4 of, now we're going to go ahead and multiply this out. So we have 5 times 3, that's going to be our 15x squared. We have a negative 6x, the negative 2 times 3. We have a negative 20x, that's 5 times 4. And then finally, we have a negative 2 times negative 4. That's going to give me a plus 8, and that is equal to 2. Let's go ahead and simplify. So we have log base 4 of 15x squared minus 26x plus 8, and that is equal to 2. All right. Now we're going to unlogify the whole deal here. So what we're going to do is we're going to make the logarithm and the other side the exponent to the same base. Okay, I'm taking the anti-log. We usually call this unlogify, but the proper term is to take the anti-log. Okay. Remember that logarithms and exponents have a very special relationship. Exponents undo logs, logs undo exponents. Here we are doing exponents undo logs. All right, so here we go. So we have this cancels out. So we have 15x squared minus 26x plus 8. Just got rid of the log equals. Here is the place where if you're going to make a mistake, it's right here. 4 squared. It's not 4 times 2, it's 4 squared. That's 16. All right. And we're going to go ahead and subtract 16 from both sides because we want to get a 0 on one side. So we have a 15x squared minus 26x minus 8, I believe, is equal to 0. All right. Now, would you look at that? We have none of these are like factorable. Like 15 is 3 and 5, 26 is 2 and 13. This is not helpful. So 8 times 15, what is that going to give me? That's going to give me 80. That's going to give me 120. I need two things that multiply out to 120, but their difference is 26. All right. So we have a long way to go. And every time you multiply them out and they give you a multiple of 12, you have to be very careful that you get the right one. So we can go really slow, and we probably will on this one because, we have, let's see, 2 times 60. We're going to have 3 and 40. We're going to have 4 and 30. We're going to have 5. What times 5? That's going to be 5. And it looks like, I think it's 24. Okay, we have 6 and 20. Okay, now remember, we're looking for a difference in these things. We have an 8, okay, and 15. I got that one from the previous one. We have a 10 and 12. Yeah, I think that's all of the little factors we have here. I want the difference to be 26. And I'm looking at this 4 and 30 and thinking that's probably a good difference that I'm looking for. So let's go ahead and try this out. We have 15x squared minus 30x plus 4x minus 8. So we see a negative 30 plus 4 gives me negative 26. Now we're ready to start factoring by grouping. This is equal to 0 on the other side now because the 16 came over, and that's how we dealt with that. So let's go ahead. We're going to pull a 5 out of the first one, or 5x rather. And then we have a 3x minus 6. Well, actually, let's pull 15. So I'm looking at this, and I'm like, wow, 3 and 6 are, those are the same thing. They're both divisible by 3, I should say. So let's go ahead. We'll pull the 15 out of here. We have 15x. What do we have left? We have x minus 2. Okay, and then here we'll say plus a 4. If I pull a 4 out of here, we have x minus 2 equals 0. Right? So we can say factoring by grouping now. So let's go ahead and deal with this. We have x minus 2. We have a 15x plus 4 that's left over equals 0. And it looks like we are going to be able to say x minus 2 equals 0, or 15x plus 4 equals 0. Now, we have x is equal to 2, or, because we already are in x terms, we have 15x equals negative 4, or x equals negative 4/15. Okay, those are my two answers that I have here. Now, the problem with logarithmic equations is you can get not an answer, okay, because logarithms can't be negative. So I'm looking at these two numbers. We're going to go all the way back up to the top to the original equation. Okay, I frequently tell my students that, almost all the types of these equations, you drag the the initial conditions through the entire problem. So when you go back to check, it all has to be good from the beginning to the end. It all has to be legal. So the example I usually give is that in the Christmas Carol, we have Jacob Marley. That's the first ghost that Scrooge saw that night. He was condemned to drag his chest of gold through the underworld. In math, we are condemned to drag the initial part of the problem through the entire problem. So if I go through and I say, well, if x is equal to 2, does that work? And if I plug it back into the original equation, is it okay? So if I plug in x equals 2, I have 5 times 2 is 10. 10 minus 2 is 8. So I have log base 4 of 8. That's positive. Plus log base 4. Again, we were on x equals 2, right? All the way back here, I should have made a note, x equals 2. All right, so 3 times 2, right? You have 3 times 2, which is 6. 6 minus 4 is also 2. So both of these worked. This one checks out. So we can say, yeah, this one works. We checked. Now we have to check the other one, negative 4/15. If I plug in negative 4/15 over here, again, all the way back to the beginning, okay? If I plug in a negative 4/15, 5 times negative 4/15, don't make me multiply that out, it's going to be negative, minus 2 more, that's going to be negative. Well, that's negative. So that one right there doesn't work. That's not a solution. Okay, not solution. So it does have a solution, and the solution is x equals 2. Okay, if you give me both of them, I take off for giving me the extraneous solution. You're not allowed to do that. You have to know this isn't an answer. So we have to go back and do that. Okay, so we checked, and that's pretty much all we have to do. So that's a good problem. Well done on that one, and thank you for watching the video, and I will see you in the next one.